I've got the pleasure to announce our next speaker. It's Prateek Purwar from CSEM talking about fingerprinting for Industry 4.0. Prateek is an R&D engineer and currently working with SBB to detect and classify faults on railway tracks. He will tell us how this can be done with semantic hatching, similar to fingerprinting or facial recognition, and how deep learning makes this technique very powerful. Prateek, show us how defect tracking can work.
Thank you, Karin.
Thank you.
So as Karin introduced, I am Prateek Purwar. I am currently working as R&D engineer at CSEM. And today I will be presenting on the topic Fingerprinting for Industry 4.0, Deep Learning for Traceability and Extensibility. So before I dive into the topic, I would like to give you a quick overview of CSEM. So we are an organization which focuses on bringing and transferring knowledge and research from academia to the industry. Currently, our headquarters is located in Neuchâtel, and apart from that, we are all over in Switzerland at 4 other centers: Zurich, Mutens, Altenach, and Landquart. CSEM focuses on mainly these 3 domains: precision manufacturing, digitalization, and sustainable energy. And my team, we have been working on these domains to bring deep learning and AI to solve various problems in these domains. CSEM has been using deep learning for a long time. So the history of CSEM, we have been using deep learning for more than 10 years, even before frameworks such as TensorFlow and PyTorch came into existence. We developed our own framework, and our research was later on converted into a startup called VD, which was later bought by a company called Cognex, who is themselves the leader in the industrial vision domain. So now coming back to our topic. We all know what fingerprinting is. We have seen this in a lot of Hollywood movies, or we are using it in day-to-day lives to unlock our phones. Now, this is a very simple picture of fingerprinting. What fingerprinting does, it extracts unique features to identify a unique human being. So the question comes, can we use a similar approach to identify objects in the industry, to uniquely identify them? And to give you a more flavor of what I am talking about, these are the few problems which we are currently handling. So for example, this is the project with SBB, where a same track is traveled multiple times a year. Now, when a track is traveled, there is a fault detected, and the SBB, when they revisit this track, they are interested if this is the same fault or it is a new one. So SBB already has a method of getting location on the faults, but the location has a measurement error, especially in the tunnels. So can we use these images to uniquely identify and produce a fingerprint for each fault? Similarly, with Leuterbach, a company located in Switzerland, a Swiss company, we are trying to uniquely identify these thousands of aluminum profiles. And you can already see the variation. Some are square, some are circular, and some have a lot of edges, and so on. Now we want to identify thousands of these aluminum profiles. So idea is very simple. I have talked about the fingerprinting. So this is how the face recognition works. So you uniquely identify and extract features which can uniquely identify a person. So for example, in this case, the length of eyebrows, or maybe the bounding box around the eye, or maybe the length of the nose. So once we have extracted these unique features, now we relate these features to a unique person, and that's how it happens on your iPhone. When your iPhone detects a new face, it computes a fingerprint for that face and see if this fingerprint is already existing or it is a new fingerprinting. And on that basis, it unlocks or does not unlock the phone. Now, when we decide to use this approach in the industry, the question comes, we have to handle the problems on the way. So for example, when trying to generate these fingerprints for the objects in the industry, we have to take care of the changing environment. With the SBB, we realize when they are acquiring images, they have to take care of the changing weather. Similarly, these faults or the objects, they may evolve with the time. And we have to have the features which are robust to this evolution over the time. Now, labeling effort. we all know this is the expensive part of the using machine learning and deep learning. The experts have to sit and label a lot of images. So if we can reduce this labeling effort using our fingerprinting approach, just imagine if a human being has to come up with handcrafted features to recognize and uniquely identify these profiles. It will be a hell of a job. The next part is, especially in case of deep learning, a lot of approaches have a limitation when they want to extend the approach. So for example, we have trained our model or any approach to identify uniquely these 4 categories. Now over the time, we get 4 new categories. What to do? Can we reuse our previous network? Can we fine-tune it and reuse it? Or we have to completely discard it and come up with a new model itself. So this is the extensibility part which we want to tackle in using this fingerprinting. So before I start going into how we did the fingerprinting, so now we want to compute these fingerprints using deep neural networks. And we all must be aware with this, but just to give you a quick overview, this is what a neural network looks like. So the green is the input layer, the purples are the intermediate layers, and the orange is the final layer. And you can increase these number of layers to compute various features according to your problem at hand. Now, once we have decided we want to use neural networks to solve our problem, do we have to design a network, how to train it, how to label it? All these tasks, comes to our mind. Instead of training from scratch or using a completely new model, there already exists a lot of neural networks which have been trained using millions of images. And the most popular of them are classifiers. So classifiers are very simple neural networks, which are, so in this case, if I give 3 images of minions to a network, the network will classify whether it is Kevin, Bob, or Stuart. And the network will itself learn these features. And so to tell, now there already exist a lot of classifiers which have been trained on millions of images like of buses, cars, human beings, etc. And they are already freely available on the internet. So the next question comes, can I directly use these networks for my problem? And this is what we call pre-trained network. So when we use this pre-trained network, instead of using them directly for a classification task, I can remove the final layer, and just before that layer, whatever the features or whatever values or elements we compute, we can use them as the fingerprint directly. So if you see in this case, no training required, no labeling effort, you can directly use this network. In case this may not work for your case or the problem at hand, because these networks have been trained with the natural images of humans, cars, and buses. And we know in industry we rarely deal with such images. So the next thing comes, can we use a network or train a network with the images or with the objects we have at our hand? And this is where I would like to suggest the use of this autoencoder approach. So this approach is very simple. You use the image and try to reconstruct the same image using this network. So when you want to reconstruct this image, still the labeling effort is 0. And that's why these networks or this approach is called self-supervised. Now when you have trained a network, you can take out the purple layer, as you can see in the slide, and this layer now starts acting as a fingerprint. So in this case, you have to train the network, but still you didn't have to label anything. Now, in case even this does not work for you, now what to do? Because these networks are not specifically trained to identify or give a unique identification to an object. They are trained to reconstruct an image. So this is what we propose as the final solution to solve this identification problem. So I propose here the use of Siamese matching networks. So these networks are very popular. So we can take the already pre-trained networks and train them in a way to measure a similarity. So instead of feeding now single image, I feed it 2 images and ask the network to come up with, is it similar or not? Once we have trained these networks, we can directly use the final layer of these networks as the fingerprints. So again, we can store these fingerprints in a database, and when a new image comes, I can compute the fingerprint and match it using these networks and get a similarity score, whether they are same or not. Now, the The advantages are here for using this approach. Less labeling effort. You do not have to label each and every category or each and every image to which category this belongs. We can directly have to label if they are similar or not. Second is, this is a very huge advantage of using this approach, is extensibility. Now, when you get a completely new image from a new category, what to do? You can still feed it to the same network, compute the fingerprint, and match it with all the existing fingerprint. If it doesn't match with anyone, so your network is already working. You don't have to change anything. In case it is not working for you, then you can use one-shot learning. And what I mean by one-shot learning is you can take few examples of your new category and train your network or fine-tune to improve the performance on all the categories, including the new category. So this is what we did with our approach, and we applied it on the 2 projects, as I already mentioned. Here we computed the fingerprints for the 2 images, we matched them, and this is what we got. So you can see the faults. They doesn't look totally similar, especially the first 2 images. There is a heavy difference in the illumination. This is a very unique case, where in the first image, you cannot see even the shape of the fault. And in the second image, you can see the shape. And the network was able to say that the first 2 images are 97% similar. And this is very nice for us. And in this example also shows a similar result. Similarly, for the Leuterbach project, we were able to come up with this approach to uniquely identify 30 profiles. And this network was deployed on cloud, where the user was asked to take an image using a smartphone, and he was given the result as a ranking of the categories which this new image belongs to. So this is the flavor of using this approach, which I have given what the results I have achieved. But what is the future of fingerprinting? So a question comes, does these fingerprints have any physical meaning, as our fingerprints have? So there has already been a research going on this front, where some of the researchers tried to tweak these fingerprints and understood that these fingerprinting elements relate to the rotation and width of the chair. Similarly, if we go into the future of fingerprinting, there can be this traceability, where we would like to trace the object to its origin, or to trace to avoid the counterfeits or the fakes. So here in this project, which we are trying also to use a similar approach to identify the origin of these gems, which country they belong to, and are they real or fake. And the final thing is, so I have explained a lot of projects about images, but is this fingerprinting approach limited to images? So no, it is not. You can feed any data. It may be time series data, it may be a chemical spectrum data, or optical spectrum data, and use it to compute fingerprints. These are a few upcoming projects where we wanted to detect or identify weeds or pollens. So to finally give you the bullets of my presentation is, fingerprinting is very much useful and advantageous for SMEs. It comes with the reduced labeling effort, and labeling effort is expensive and you can reduce your cost. The second is extensibility. As you have already explained, that you can extend your already existing model and use it again for other, make it work with new categories. I hope you like the idea and the approach of fingerprinting. So we work with these innovative approaches. So if you are interested, you are welcome to work with CSEM. Thank you.
Thank you very much, Prateek. This was really an exciting presentation. Lots of new opportunities popping up in my head. And there were also quite some questions coming from the audience. The first one that came in is actually, can you say a bit more on the failure of the pre-trained networks examined? How useless were they?
So we actually, they were not completely useless. When we started our fingerprinting project with SPB, we actually we directly use an architecture called ResNet 50, and directly using those features for the fingerprinting. And they were not bad at all. But later on, we wanted to improve the performance, and thus we started using Siamese approach.
I see. What I was wondering myself, it all works with pictures, right? Taking it with different lights at different times of the day, in different weather, in different conditions, the quality of the pictures, how much does this actually affect the outcome?
So this is a very interesting question because this makes you go in the domain of data augmentation. And as you can see, these neural networks are really smart if you make them learn with these augmentations. So if we have already tried in this project and also in other projects where we try to, you can make the network learn how much variation is it's to be ignored and how much variation is not to be ignored. So for example, if the illumination is completely changed, you can ask the network to ignore these changes.
Oh, very nice.
Yeah.
And there was another question actually coming in from the audience. Somebody wanted to know how high is the rate of false positives?
So for the false positives, in fingerprinting, I do not have the exact numbers, but because in the case of SBB, we were using it in a hybrid mode. Like we were using the location of the false in addition to the Siamese approach. So it already reduced the use case itself. So there were very less false positives in this case.
Okay. So Prateek, thank you very much for this exciting presentation. Hope to hear more from CSEM in the future about
we would like
this
to
technique.
work on this and such innovative approaches with as much as we can.
And have a great day.
Thank you.
Thank you.